A spring is a flexible metal device that returns to its original shape or position after it's stretched, squeezed, or twisted. Springs were first used in clocks during the 16th century and starting in the late 1800s in chair seats and bedding. Today, springs pop up all over. They're crucial components of modern technology. Different types of springs include compression on the right and extension on the left. During use, these torsion springs will twist at one or both ends. Workers start with rolls of steel cord. The cord diameters range in size depending on the type of springs being made. A machine called a dereeler unwinds the roll, feeding it to a computer-guided forming machine. This forming machine forces the cord through a channel, shapes it into a coil, and then cuts it into segments. Small wheels and a metal shaft guide the cord into shape. These are torsion springs for use in the automotive industry, which relies heavily on a variety of springs. The average car, for example, has about 350 of them. A cone-shaped yellow sensor detects the correct angle of each spring. A good reading is required so the machine can move the next spring forward through the channel to be formed. This machine can produce up to 2,000 springs per hour, depending on their size. Here, another larger forming machine creates extension springs that are over 6 inches long. A mechanical arm grabs the coil and chops it into segments after it's formed in a channel. As the coil emerges, another mechanical arm steadies it to prevent it from vibrating. This keeps the spring tension constant, enabling the machine to produce at top speed. In slow motion, you can see how the machine grabs the coil's first ring and bends it to form a hook. This all takes place as the coil emerges from the channel. A vise then secures the last ring on the end of the coil, while another arm twists it to make the spring's other hook. Slowed down, you see how 2 arms surround the coil being held in the vise. One arm then grabs the last ring while the other arm twists it upward. This machine makes compression springs, a model with tapered ends that's often used in seat belts. A metal probe detects the correct length of the springs after they're formed. The machine has 4 rotary shafts called cams. A computer ensures each spring has the desired specs. The springs are also heated to relax the metal. This gives them the ability to retain their shape after flexing. Another machine creates longer, thicker torsion springs. It shapes the cord into a coil with a shaft and then passes it over a tube to steady it. This ensures the spring will have the required tension. Springs can be as thin as a human hair or as thick as a broom handle. Train wheels, for instance, include some of the industry's thickest compression springs. This machine makes another type of spring, often called wire forms. They're flexible steel cords curved or bent at an angle. These ones, shaped like a W, are used in ovens. Here, a worker places a spring into a machine that makes its hooks. He uses an adapter to avoid hurting his fingers. He places each one individually because specs for springs can vary by minute amounts. This company makes some springs with hooks made of 2 rings instead of 1. Clients order them this way because the hooks are more durable. Custom orders for springs can range from just a few to many thousand. This is another type of wire form. It'll be used in a firearm. A worker assembles it by hand because it's so intricate. After joining 2 base pieces, he places them into a small die. Using a foot pedal, he controls the die to bend the segments and complete the assembly. To check the compression spring's tension, a worker tests it with a weight gauge. The correct tension varies depending on what the client wants. A 1.5-inch long spring, for example, might need to withstand 5 pounds of tension when compressed to 1 inch. To test an extension spring, workers just add hooks to the weight gauge. Whether they're extension, compression, torsion, or wire form, and whether they're inside pens or satellites, springs prove that some old ideas definitely still work.